Hello, my name is Muhammad Narendra Hermawan. Today I'm going to present about my final report regarding rewinding of induction motor in Indramayu, 500 kilowatt in PT.Pindad. Okay, so here is the technical specification for the motor that we want to maintain and repair. So the product is a motor from Indramayu, and I'm going to repair or maintain it. The output of the motor is 500 kilowatt, and the voltage that it produces is 6000 voltage, and for the current is 63.8 amperes, and it runs on 50 hertz. The power factor is 0.8, and the speed of the motor is 743 rpm. The insulation class is class F, and the weight of the motor is 4570 kilograms. Okay, so the first thing that we want to do is to inspect the motor. So the first step, it called the incoming inspection, and it also can be called static testing. These inspection are crucial for ensuring the reliable and efficient operation of the generator system, and this process involves evaluating key components such as the starter, rotor, exciter, shaft, and housing. And throughout control condition, static testing identifies potential issues or weakness in construction or material that could lead to operational failures. And the first component that we want to inspect is the most important one, which is the starter and rotor. So the starter, which consists of stationary coils, and the rotor, which rotates within the starter, are subject to scrutiny. So we need to make sure that that component is aligned, balanced, and the insulation are proper to prevent any malfunction that could impact the generator's output. And the next component is the exciter. These components are responsible for providing the initial current to the rotor's winding, and it is also carefully tested to ensure its ability to initiate and maintain the generator's electrical generation process purpose. Okay, and the next component is the shaft. The shaft is the one that connects the rotor to the mechanical drive system. It is also examined or inspect for the integrity of the structure, and it is aligned or not, and also the potential stress point of the shaft. And the last one is the housing surrounding. This component is inspected for sign of wear, damage, or overheating, as it plays a crucial role in safeguarding the internal elements from environmental factor, and also ensuring the generator safe operation. So in this test, which also we can call it static test, we measure the conductor resistance and also the insulation resistance for the stator, heater, and resistance temperature detector, or RTD. But I will explain it further later on about the static test. Next is the process. So after we carefully inspect the motor, finally we maintain or repair the rotor and the motor. There is 6 steps of the maintenance process. The first one is dismantling. So we need to remove the accessories. They could include auxiliary systems such as control panels or any attachment that are essential to the generator's primary function. So we remove the first one that we usually remove is the front and rear cover of the generator, which enclose its internal working. Then the guide ring, a component that directs our airflow for cooling purposes, is also removed. The next part is the important one, the rotor, the component that plays a critical role in generating electricity. We carefully extracted it from the stator, the rotor. So after we dismantle it, the next process is to rewind the stator winding. The first we need to do to rewind a stator is to test the material, to test and check the material. This step involves assessing the properties of the existing winding material and referring to a design drawing to ensure consistency and accurate placement. And then we disassemble it. This process begins by carefully dismantling the old winding, of course. Then the existing wedge isolator, which hold the winding space, is also removed. We dismantle it. Then we clean it. We clean the winding and we insert the new winding. The new winding, we create a new winding coil using a resin-rich system to ensure the insulation and durability is improved. Then the new winding coil need to be tested to meet the insulation class F standard based on the insulation class I stated early on. Then we put it up the winding into an oven to enhance the effectiveness of the insulation. Then we varnish it and coated it to further enhance the insulation and protection against environmental factors. And now the new winding is ready. So the next step is to recondition the rotor. So this process aims to refurbish the starter windings to ensure optimal performance, insulation, and reliability of the generator or equipment. This set of instruction outlines the step for the reconditioning rotor is used to maintain the optimal function and balance of the components. So this process involves the reconditioning of the bearing, and also balancing the bearing itself. So for the reconditioning of the bearing, as it's said, the bearing is reconditioned. Of course, according to the standardized bearing size, the size have to be matched. And next, we need to balance it also. We test that to ensure the rotor operates smoothly and without excessive vibration. Then we move on to the next process. Now we maintain the starter. The starter will undergo two process. The first one is called PVI, or preservation and visual inspection. In this process, we inspect the starter housing to address any sign of damage, wear, or corrosion. And also we conducted a test called hotspot testing. This test is used to identify areas within the stator where heat accumulates excessively during operation. To identify hotspot is very crucial, as they could indicate potential insulation or cooling issues that might affect the starter's performance and longevity. Then we clean the stator and also improve the stator insulation resistance. The next process is the oven process. In this step, we focus on treating the starter coil to enhance its insulation properties by placing the starter coil in the oven at 130 degrees Celsius for 12 hours. So after we done inspecting the winding, the rotor, and the starter, we assemble it back together. And the last step is to test it. Of course, we test whether the motor is already secure or not, and also conduct a running test and vibration test, and also temperature test. The next part is processing inspection. We already test the physical wear of the motor. Now we need to test whether the electrical component of the motor and the mechanical parts of the motor are functioning correctly. So there are three tests that we need to be conduct. The first one is called electrical test coil. So the step involves conducting electrical tests on the coils of the machinery. As we know, coils are essential components in electrical system. And these tests aim to verify their functionality, integrity, and adherence to electrical standard. Various parameters such as resistance, insulation resistance, and impedance might be measured to ensure proper coil performance. And the next thing called electrical test of starter winding. The starter winding, a critical part of electrical machinery, undergoes comprehensive electrical testing. These tests aim to assess the insulation quality and overall electrical integrity of the winding. Insulation resistance, the electric strength, and other electrical properties are evaluated to ensure the starter winding can withstand the expected electrical stress without failure or breakdowns. And the last processing inspection called dynamic balancing. This test present the result of the dynamic balancing test involve analyzing and adjusting the mass distribution of rotating components like rotor to minimize vibration and ensure smooth operation. Okay, now is the final inspection. As I said before, the static test is a test. There is static test and there is dynamic test. The static test is where the machine is not running. We test the machine while the machine is not running. As for the dynamic test, the test is conducted while the machine is running. The purpose of the static test is to assess the resistance of conductive elements and the quality of insulation within the different circuit of the motor. And as for the dynamic test, we to evaluate the motor's performance with various factors such as electrical behavior, mechanical dynamics, thermal performance, and operational noise. So in static test, various measurements are conducted to assess the resistance of conductive elements and the quality of insulation within different circuit of the motor. This measurement helps to ensure that the motor's electrical components are functioning correctly and that proper insulation prevents electrical leakage or malfunction and other unnecessary stuff. And this static test is very crucial to verify motor's electrical integrity before it is put into operation or before it is running. In this test, there are three components that we need to inspect. There are two variables that we need to measure: the conductor resistance and the insulation resistance. For the conductor resistance, the measurement is to provide information about the conductivity and integrity of the conductive path. And for the insulation resistance is used to assess the quality of the insulation material that separate conductor from each other and from the status core. And of course, higher insulation resistance indicates better insulation quality. We measure it for thermometer, stator heater, and RTD, resistant temperature detector. So, as I said before in the second slide, third slide, sorry. Static test is conducted 2 times, before the maintenance and after the maintenance. The goal is to find the malfunction components. So here is the report of the test. By the way, we measure it at 25 degrees temperature and 65% RH. And this one for the starter, as we can see here. For the starter, the insulation resistance is 0. It means that there are no insulation at all. There is no resistance at all in the meter. So of course we need to add a new insulation or enhance the resistance of the insulation. And for the heater, it can be said that it was normal. There is no malfunction at all. And for the RTD or resistance temperature detector, is also malfunctioning. If the RTD is supposed to be consistent, the conductor resistance is supposed to be the same or at least consistent every time we measure it. So we also need to replace the RTD components. And after we maintain and repair it, as we can see here in the report, that the insulation resistance is not 0 anymore. There are resistance in the insulation, so it is not malfunction anymore. And for the RTD, the reading of the measurement is consistent, so the maintenance is correctly conducted. And now the dynamic test. The dynamic test is the test where we test it while the machine is running. The Okay, in dynamic test there are 5 tests. The first one is no load test. This test is done under a no load state, which permits them to operate without any restriction because there is no load. So this test is conducted because it can measure the magnetization current or the current used to produce flux in order to the motors spin. The next is fan airflow. This test is conducted to verify the fan's efficiency in cooling the motor during operation. And air circulation is very crucial for maintaining the motor's temperature within safe limits. So in this test we used a anemometer to measure the airflow from the motor's fan, both from the intake, the front side, and also the exhaust side, the back side. The next one is the noise test. The next step is noise test. This step is to measure the noise level of the generator. So the noise level are measured at different positions around the motor, from left, right, front, and rear. We measure it. While we measure it, it is also operating under no load condition. So noise measurement help to assess that the motor acoustic output is operate at acceptable noise level or not. The next one is the heat run test. The purpose of heat run test is to determine how much the motor temperature varies when it is utilized for a certain period of time, which is typically throughout the day in the case of electrical machine. So it is only reasonable that when running, temperature fluctuation must be taken into account. So here is the measurement or the reading from the dynamic test. This is for the no load test, and this is for the fan airflow. This is for the noise test, and this is for the dynamic test. This is for the heat run test, I mean. Yeah. From the test, we can conclude that the induction motor is running perfectly after maintenance. And I think that was all for my presentation. Thank you for your attention.